So I wonder has recording started yet? Yes, it has. Okay. So good afternoon. Good Friday afternoon. So today we're going to deal with teen war analysis. Okay. But before we go on, I will put on a vote again for term test 2. So it can be on March 18, on March 19, on March 20th. Can anyone tell me how are all your schedule on these 3 dates? Anyone, please? Those of you that are here. Anyone?
I know we have, for heat transfer, we have test 2 on the 19th, I'm pretty
So
sure.
19 you have heat transfer.
Yeah.
Anyone else? Anything on the 18? I have midterms on 15 and 17, so please not 18. I get you there. Anyone else?
I think there's a midterm for statistics on the 17th.
So there's a midterm on 17. Okay. So anyway, I'm going to put, so I will put a vote on, we'll do the 20th. I think 20th is a Saturday. Are you okay on a Saturday? Anyone? I have no reaction yet. Okay. Anyway, I'll put a vote. We go on from there. Okay. Right. Thermal midterm on the 15th. Yeah, that's Dr. Cotton one. Okay. Now today we are going to look at shearing stress in teen war members, and I believe this lecture today will make you understand better regarding the topic that we taught before reading week, which is failure at the joints. Okay, so today's quiz was regarding failure, how the nails will fail or the gluing section will fail. Okay, so this will shed more light. Okay, this I have a football soccer on the 18th of March, you cheeky sort. Okay, so this will shed more lights of your understanding of the topics. Okay, so if you look at a textbook, this topic on teen war come later. Okay, and I wish it did not, because I already taught you how to design the shear flow. Okay, but there's more to talk about. Okay, so now this lecture is very specific for teen war members. Okay, it is only applicable for teen war. So far, what we have done, right, is for tick war. Okay, now this is for teen war. So it's a teen war analysis. Okay, so there are two types of configuration. So if I may, there are two configurations. And I did introduce this to all of you before. And one is known as the white flange. And the other configuration is known as the box beam. Okay. Right. So what you see in the diagram, okay, so I'm going to do box beam first. Okay, so this is box beam. My bad, I should have written it the opposite way. Okay, my bad, I should have written box beam first and then white flange. So there are two types. So one is known as box beam and white flange. Okay, so let's look at box beam. Okay, so what you see on the left hand side. Now all these figures are available on Avenue to Learn, by the way. Okay, I'll upload some of these figures. So let's look at box beam. And I will highlight what is the unique thing regarding teen war and tick war analysis also. Okay, I'll do. So first of all, this is a box beam. Okay, so at point A, I usually like to label this. Okay, that when I do the analysis is at point A, you see the dot. This is our start point, right? And then E below, over here at E, I like to label it that this is my end. Okay. So for box beam, you will see that there's one start point and one end point. Okay. And what you see on those pink arrows, okay, all these are your shear flow Q. Okay, all these are your shear flow. Okay. So you can see in the diagram, the longer the longer the arrow, so you can see down here, the longer the arrow, right, the higher, okay, the higher the shear flow magnitude. So if we look at the formula for shear flow, okay, for if you look at the formula for shear flow, we have it as what? Q is equal to VQ over I. Okay, so that is what we call the shear flow, right? So on a box beam, what you see from A, the shear flow will one go towards the left and one go towards the right. Okay, and the controlling direction, like what I've taught you guys before when we were doing the when I introduced you the shear flow, the control is the web. So the shear flow direction is controlled by the web. Okay, it's controlled by the. What do I mean by that? Okay, what do I mean by that? If you have a shear force V coming in that direction, okay, the shear flow, okay, the shear flow in the web will also follow the direction. Okay, so where I'm highlighting, they're all coming downwards. Okay, so that's where when you design your shear flow on the flange, so what we call here top flange, down here is our bottom flange, right? Because of the direction of the shear flow in the web, which is the control, that is why the arrows at point A leading to the web, okay, so at this region down here is going towards the left, at the other side is going towards the right, and then at the bottom flange is coming in on the left hand side, is going towards E, on the left, and both are going to point E. Okay, so that is what I mean by designing the shear flow. Okay, so when we call it flow, I want you to have the impression when you use the word flow, it's very similar like fluid flow. Okay, so it's at point A, you introduce water. Okay, you can look at it as water if you want to. Okay, so the water comes, it will go towards the right, come down and come back in. Okay, so now what is the difference between thin wall and thick wall? Okay, there is some similarities, but there are differences also. I repeat again, there are some similarity and there are some differences. So what are they? So let's look at the difference first. Okay, so on the side, I'm going to sketch thick wall analysis. Okay, that's what we've learned so far. So thick wall, in this case, I'm going to draw. I'm going to sketch. Okay, same thing. Okay, for thick wall, I'm going to sketch. Where is my mouse now? My mouse gone missing. Okay, I'm going to draw thick wall box beam. Okay. So this is thick wall box beam. Right. So this is thick wall. Okay. So now, what is the difference? Okay. Let me highlight to you what is the difference. Okay. The difference is this. If you look at from let's look at thin wall, okay? Or let's look at thick wall. Everyone is familiar with thick wall, and we're going to find the shear stress. Okay, so shear stress is equal to, oh, you guys can see, my apologies. Shear stress is equal to VQ over IT. Okay, that is for thick wall. For thin wall, the shear stress, okay, shear stress is also equal to VQ over IT. Okay, now if we want to find, okay, if we were to find, for example, I will always ask you, okay, let's find the stresses at point alpha, right? That's a typical question. Let's find the shear stress at point alpha. Okay, so you find the shear stress. So the same thing, you have to find where the centroid is, right? So this is the centroid, right? And then the area that we are going to consider, we are going to consider this area. Okay, we're going to consider this area. And then the thickness will be, which is the thickness? Anyone? Is it the horizontal or the vertical orientation? Anyone? Anyone? So this is the thickness that you would take. Yes or no? Right? So that's for thick wall analysis. For thin wall analysis, okay, for thin wall analysis, right, you have to consider this, okay, for thin wall analysis. So let's say now we want to find the stress over here, right? And the stress over here is known as alpha. Okay, so if you look at this, it's very similar, right? It's on the vertical flange, okay, before the web, okay. The area, the first moment of area is also the what? The first moment of area is also the same, okay. The first moment of area is also this area. Now this is the similarity, okay. The first moment of area is the same, right? Now the thickness is different. In thin wall analysis, the thickness is this direction. Can you see the difference now? Yes or no? Right? For thin wall analysis, the thickness of the wall is the vertical section for thin wall, whereas for thick wall is the horizontal. Okay, big difference, yes? Okay, then you have another difference. Okay, the other difference is you have to consider Q. Okay, what do I mean by that? So if you look at this part that I've circled, right? At point A, the shear force, so the shear flow split left and what? Right. So for this case, the formula will be tau, the shear stress will be equal to VQ over IT, and you have to include a 2 down here. These two, because you have a left and right Q. One of the Q from point A will go towards the left. The other one from point Q will go towards the right. Okay. Whereas for thick wall, no, nothing at all. Okay. Now, let's look at what will happen. Some of you say, okay, Eugene, we get that. We are good to go. Now, where is the more similarity? Okay. Now, let's say now, are we okay? Are you guys okay? Anyone, any questions so far? No? Okay.
Just to confirm, that 2 is a squared on the T, right?
No, it's a 2, not a square.
Oh.
It's a multiply of 2, not a square.
Oh,
left
got
and
it.
right.
Okay. Okay.
Okay.
Got it.
Okay. Okay. Now, that is one difference. But how about now, if we were to find, okay, now let's say we are going to find at beta what is the stress, right? The beta. So we found the beta also. Okay. So beta on the thick wall and thin wall is about the same location, right? The same location. Now, what thickness do you